So let's start again. So we've got this original amount of hydrogen and small amount of helium present. Now, the reason why the low mass star cycle took this path was because originally the amount of hydrogen available was small. It was enough for a star to be produced, but it would take this path in its life cycle. Now, if the mass that we have originally is very, very large in comparison to the low mass star cycle, okay, what will happen is the fate of that star that is born will take a different path. So you've got a lot of hydrogen compared to before. That means you've got a lot more gravity compared to before. So when gravity brings in all of this mass, you will get more collisions between particles, and as a result, you will get a protostar created. Again, it is a hot ball of star. It's collapsing under gravity, but because there's a larger gravitational force, the temperature here will be much larger. Eventually, what's going to happen is gravity is going to continue to collapse the star, and that will trigger a high enough temperature for fusion to take place. And again, this star, as soon as fusion starts to take place, the star creates a outward pressure balancing the inward gravitational pressure. And this star, because it has more mass, it has more gravity, it's burning through, or it's fusing hydrogen to helium at a much faster rate than a low mass star. So although we have a lot more mass, often it's easy to think because there's more hydrogen available, the longer the star will live. But because there's more hydrogen, it creates a higher amount of gravity, and this process of hydrogen to helium fusion happens at a faster rate, which is why these stars don't stay in this phase as long compared to the low mass star. So both of them are main sequence. They both are converting hydrogen to helium via fusion. They both have got the outward pressure of fusion balancing the inward pressure of gravity, and most of the lifetime of the star is spent as a main sequence star. Now, eventually, what's going to happen is this hydrogen helium fusion that is taking place in the main sequence star, the hydrogen is going to run out, and the star, again, it expands and cools after going through a series of intermediary steps and triggers further fusion from helium. But now, rather than being limited to fusion of helium to elements such as carbon, oxygen, and nitrogen, it has more gravity because there's more mass available, and as a result, there's a higher temperature, and this helium fuses elements up to iron. Fe is the symbol for iron. So that's the difference between a red supergiant and a red giant. They both have expanded and cooled from the main sequence when that cycle, that stage finished. Both fuse helium, but helium fusion does not stop just with carbon and oxygen, nitrogen with the red supergiant. It continues to fuse elements all the way up until iron. Now, the next stage, eventually what happens is the helium runs out, and that inward pressure of gravity is still there, it hasn't gone anywhere. The outward pressure due to the fusion is going to stop. So the star rapidly collapses, and this rapid collapse creates this supernova explosion. So the star rapidly collapses, hits the center, and all those particles bounce off the center. That explosion, or those particles bouncing off the center of the star, is called a supernova explosion. Now here the temperature is high enough for further fusion into heavier elements above iron. Okay, so heavier elements above iron. So all the elements up to iron are produced in a red giant or a red supergiant. And when the supernova explosion takes place, then all of the other elements that we know that are in the periodic table are produced there. Now, the explosion leaves behind the core. The core of the star is still in the center. And that core could end up being a neutron star or a black hole if there is slightly more mass that remaining in that core. So these are the two centers of that supernova after the star has exploded. So not all the star disappears in the explosion. The center of the star remains, and that is either the neutron star or the black hole. The neutron star is completely made out of neutrons. Okay, and it in size is around about 30 kilometers in diameter, so not very big, smaller than most cities and towns, but is very, very dense. It's the same density as the nucleus, where you've got protons and neutrons squished together. So what's happened here, it's the electrons have merged into the protons in the nucleus, and they are all stuck together as neutrons. Now, if there was a little bit more gravity present, those neutrons will continue to kind of merge into one another into a finite single point, and that is where we have our black hole, where all of that central core has been squashed up into a small, tiny singularity. Now, there's some interesting things about a black hole. Even light cannot escape the surface of a black hole because the gravity is too strong. Even light cannot escape. So, as a quick run through, you've got a large amount of mass present originally. That mass collapses under gravity, creates a hot ball of gas that continues to collapse under gravity. Enough temperature is reached for hydrogen and helium to produce hydrogen helium fusion to take place. This creates an outward pressure that balances the inward pressure of gravity. Most of the star's lifetime is spent in this phase. Eventually, hydrogen runs out, and through intermediary steps, which we won't discuss at this stage, the star expands and cools, and eventually helium fusion is triggered, and the outward pressure and inward pressure balance again. And here we have fusion up to elements of iron, and then eventually helium will run out. The star will rapidly collapse and bounce off the core. This is what we call a supernova explosion. In these high temperatures of the supernova explosion, further fusion of elements takes place beyond iron and all the way up to uranium. What's left is a central core. Either it is entirely comprised of neutrons, or it is a small region where all the mass exists and even light cannot escape the surface of a black hole because the gravity is just too high.